Okay, so welcome to Math2526. So last class we introduced sample mean, sample variance. Right? So sample mean is just the average. So add them up divided by n. But for sample variance, we just add them up. So divided by n minus 1. Right? Summation for xi minus x bar square. Add them up, we should divide by n minus 1. So here we can write this as a summation of xi, then divided by n. So here divided by n, here divided by n minus 1, so y divided by n minus 1. We say there's a degree of freedom. Okay, so again, so this is important notation. Instead, average should be divided by degree of freedom. Okay, so sum of something then divided by degree of freedom. Okay, so we explain why here is degree of freedom is n, here degree of freedom is n minus 1, because we say those n numbers in numerator like x1 minus x bar, x2 minus x bar, and xn minus x bar. These n numbers, degree of freedom n minus 1, because we find they have this relationship. Add them up, add those things up, equal 0. Equal x1 plus x2 plus xn. So minus x bar minus n x bar, right? So we know this equals 0. So for this reason, we say the n numbers in numerator, their degree of freedom is n minus 1, because they have this relationship, or because like this one xn minus x bar equal negative those things, right? So if we have this, so this one is completely determined by others. So no degree of freedom. Okay. So in this situation, how can we find a confidence interval for mu? So if we know sigma, we can use this formula. So if we don't know sigma, then we just replace sigma by s. So replace population's standard deviation by sample's standard deviation. So it seems we can have this formula, right? X bar plus minus z star times s over radical a. But we say such a formula is not so good. So here why? So we say this formula sometimes good, sometimes not good. We can say in some cases okay, in some cases not so good. So we want to check when this formula is okay, when this formula not okay, and why. So let's review how can we derive this confidence interval for mu. So we say just from sampling distribution, we say x bar follows us, right? When we take a sample, then we have this result, right? X bar follows us. So this is always true. This is just actually sampling distribution, or sampling is all centrally limited salient, right? So from here we continue to general or normal. So x bar. We can change it to this general normal. We can change it to standard normal. Yeah. So so x bar this minus mu divided by sigma. So divided by this. So this thing follows standard normal, right? So from the general normal to standard normal. So we say this. We denote this as z. So okay. Okay, so now we say this is follow normal, stand normal. So then when this sigma, if sigma is replaced, by s, then the trouble is here. If we replace by s, this will be no longer standard normal. So this will do not follow standard normal. Okay, then we want to check follow what. So the result is follow a new distribution. We call T distribution. Okay, so this follow normal distribution or Z distribution. Standard normal, typically the standard normal is Z distribution. Okay. So for T distribution, we have a degree of freedom. So for T distribution here, degree of freedom is n minus 1, just the degree of freedom in the variance. So the conflict interval is, so here check Z table, here we need to check T table. So conflict interval is, so just like the same thing. Like, okay, if we have this like, okay, so here also the 0, there's a T distribution. Okay, T distribution with degree of freedom. Okay, so this cut point, so become T star. We call it the T star. So before from Z table, so Z star. So here T star. So the formula, so we should change this Z star to T star. Then this formula is okay. Okay. So this is formula for conflict interval for mu. So just x bar plus minus T star times S over radical A. Okay. So how to find this T star? So just like how to find Z star, we need to check a T table. Okay. So check a T table. So we have a Z table. So by now we have a T table. Right. So Z table. So the table is for standard normal. Then we have the T table. Okay. So here is T table. Let's say there is a T table. Okay. So what does the T table tell us? This T table tell us, so tell us the cutoff point. Let's say okay, 0. Okay, so let's say what is this number meaning? So let's pick some number. Let's say here this number is this is a degree of freedom 5. So this is about a T5. Okay, so here's the degree of freedom 5, right? And so this is a 2 point, this is like a 2.015 is cutoff point. This is cutoff point such that, so here 1 tail, 2 tail, oh, so cumulative probability. So what the 1 tail means, like cutoff point here, the 1 tail, this side is 005. So 1 tail 005. So then cumulative all the way down is 95. So we denote this number is T 0.995, right? So this is like this one is a T cutoff point for 0.95. Okay, so this is 1 tail 005. Then if we check a 2 tail, so 2 tails 10%. So actually 2 tail is 2 times 1 tail. So because there's a T distribution, it's just like standard normal distribution, is symmetric. Okay. So you understand there's a table. There's a table just give me, so those numbers are just a cutoff point. Okay, or just like a T star. Okay, so now let's consider this problem. So in our class, we have 25 students, and we find in our class, the average GPA is 3.1. So this 3.1 is X bar, right? 3.1. And also with standard deviation. So this standard deviation is from our class, from sample. So so we have the information from our class. We can find the class size, class mean, and class standard deviation. So this standard deviation is sample, so S. Okay. So based on our class's information or the sample's information, we wanted to give out a 90% confidence interval for mu. Okay, so the formula is, we say just X bar, so plus minus T star, right? T star times so S of radical N. So here we just plug in X bar is 3.1. So S is 3 this, and N is 25. So we only don't know there's a T star. So T stars are here, 5, and the radical 25 is just 5, right? Okay. So here we just need to find a T star. So what is the T star? So for this T star, we need to check a T table. Okay, so T table. So T table, at first, we need to determine degree of freedom. So here, degree of freedom is N minus 1, so equal 24, right? So degree of freedom is 24. So confidence level is 90. So let's check this T star. So let's go back to T distribution. Okay, T distribution, degree of freedom is 24. So we just check this line. So this line for degree of freedom 24. So the confidence level is 90%. So what does this mean? So this is like 90. Yeah, we already checked this. Let's say, yeah, so 90. So let's say confidence interval, the confidence level is 90. Meaning from here to here 90. Okay, so then 2 tail is 10%, right? 1 tail is 0.005. So we just check 1 tail 0.005. Okay, so check this. So 1 tail 0.005, 2 tails 10%, right? 0.10. So we just check, okay, so degree of freedom is 24. So we find cutoff point is thus, right? Let's say like yeah, 1 tail 0.005 and degree of freedom 24. So this 1.711 is our T star. Okay, and also we also can check from here like a confidence level 90%, and the degree of freedom. So we can go up like degree of freedom 24. So we get this number, right? So this number we can determine from confidence level or from one tail percentage or two tail percentage or cumulative. The cumulative is 95. So all those four things are just actually the same, right? So, but anyway, so we get this T star. So let's say in this case, the cutoff point of T star equal 1.711. So then by now, so go back to here. Oh, so the problem becomes really easy, right? So equal 3.1. So plus minus 1.711 times 0.35 over 5. So use calculate or Excel, we can easily find this low bound, upper bound, right? So we finish the job. So we can find the confidence interval. So this is for general situation. We do not assume we know the sigma. So this interval is completely get from the data, right? So this is a real statistical question. From the data, from the data we make the decision. Or instead, we say let the data tell the story. Right? We should not assume this, assume that. Okay. Okay. So now we have okay. So we can have many of those kind of problem, right? Let's say like okay, we wanted to estimate something. Like we wanted to estimate the income, average income maybe. So we wanted to estimate average income. Yeah, for house income in the city. Average income in the city. So we do a survey. We check so many households. So this is a sample size. Like we take a sample, we check so many people, and we find their average thus. So with standard deviation thus. So this standard deviation is from sample. We do not assume, right? We just find this. We calculate it from the data. We calculate this. So this is S. Okay. So based on those information, we wanted to give a 95% confidence interval. So the formula is x bar plus minus t star, and this is radical A. So by now we have x bar, we have S, we have N. So only thing we just need to find a t star, right? So there's a t star. So again, we just check the t table. Okay. So at the first we the degree of freedom is N minus 1 is 29, right? So we just check this, degree of freedom 29, and the confidence level 95. Right? So let's go back to the T table. Okay, T table. Degree of freedom is 29. Okay, we have the 29. That's good. This line, right? Degree of freedom 29. Confidence level is 90%, 95%. Okay, so we find this cutoff point is T star is 2.045. Okay, so this is what T star. Okay, so confidence level 95. So 95 means outside. So here 95. So this is the cutoff point. So this two tail is 5%, right? Two tail 005. So two tail. So here we it's the one tail is 0.025, right? But in this case, it seems we just check a two tail. So like here is 95, then outside two tail is 005. So we can check 005. So this is two tail 005, right? So we know we get the same column, same number. Okay. Okay. So let's say that T star equal 2.045. So now this problem is so simple, right? So T star equal 2.045. So we just plug in here. So x bar, let's say, so this by now is either equal 87,550. So plus minus 2.045. So multiply this over radical 30. Okay. So for those calculation, we can use Excel, right? So we can get this conclusion. Like we have 95% to make this, to conclude that, to say the average income in this city will be between this number to this number, right? Okay. So we say, so by now we have a T table, or a T table, Z table, T distribution, Z distribution. So what's the relationship between this between the two distributions? Okay, so we can check from the graph. So this is those graph produced from computer. We say, so those if this T distribution degree of freedom is 1, saying this degree of freedom 3, this degree of freedom 8, and this dash line like this one, and the yellow one, so yellow is degree of freedom is 30. So we can find when the degree of freedom quite large, this T distribution were close to standard normal. So their relationship is like this. We say when n sample size become quite big, then there's T distribution and will close to Z distribution, and T and Z no much difference. So such a result in statistics, we call this as law of large number. So law of large numbers means that if sample size quite big, then we don't care Z table, T table, or Z star, T star. It doesn't matter. So if sample size quite big, we say this formula x bar plus minus the Z star times ace over radical n. This is also okay. Okay. So actually, so from the table we also can see this. Like let's say from this T table. So this is Z star. Last line is Z star, and those are T star. So we can say if samples degree of freedom 100, 1000 degree, or sample size very big, we can say those two lines almost the same, right? No different, no much different. Like here, Z is 95% confidence. This is 1.96, and here is 1.962. Right? So when n quite big, the difference is not so significant. So we can use Z star, T star doesn't matter. But for the sample size quite small, like let's say so here Z value, Z star is 95% confidence 1.96, but if this degree of freedom quite small, you can say this is 4 or 12 or so we can say those difference is quite huge, right? So we can say if degree sample size quite small, we should use T table. We should find a T star. If sample size is quite big, we can use Z star. We can use Z table. Okay. So last class we mentioned this. We talking about let's say we talking about confidence interval for proportion, right? For P. So the formula is P hat plus minus Z star. So this is P hat Q hat over radical n. Alright? So this P hat Q hat is just we can regard this sigma. No, this is S. Okay. So logically, this star should be T star, right? But because usually this n quite big. If we do a survey or one yes or a yes or no questions, then n should be big. Like if you do a survey, you cannot just only check 10 people, because check 10 people check their opinion. You should check many people, right? So you should at least maybe usually we'll check 100 people, 1,000 people, right? So here if n is quite big, then we say we can use this. Okay? Okay, so those are topic for estimation problem. So we say the formula is, so let's review here. Formula is just like x bar plus minus C star sigma. If sigma is no, then sigma over radical n. So if sigma is we don't know, replace sigma by s, then this Z star should change into T star. But if the sample size is quite big, then we still can use this Z star, right? Just like confidence interval for proportion. Okay. So this is today's topic. So those materials should be easy, right? Okay, so we can stop here.